So how did one of the most ambitious machines ever built become one of the biggest failures in aviation history?
It was the biggest mistake we did to purchase A380.
And if it really was a failure, why are airlines spending billions of dollars to keep it flying today? This is the Airbus A380. Airbus wasn't trying to improve the Boeing 747. It wanted to replace it completely. 2 full passenger decks, from the nose all the way to the tail. Not just a small upper section like older jumbo jets. 2 complete floors, stacked one on top of the other, running the entire length of the aircraft. No commercial aircraft had ever attempted anything on that scale. At nearly 575 tons fully loaded, it's roughly the same weight as 1,500 cars, all lifted into the air at once. But those impressive numbers created an even bigger problem. Building a giant is much easier than moving one into existence. Every time an A380 leaves the gate, one of the most expensive operations in commercial aviation quietly begins. A fully loaded aircraft carries more than 320,000 litres of fuel, enough to fill roughly 3,500 family cars. On a route like Dubai to Los Angeles, it burns 11 to 13 tons every hour, and fuel alone can cost well over $70,000 by the time it lands. Add crew, maintenance, landing fees, and catering, and operating this aircraft can exceed $40,000 to $55,000 every single hour. So why would any airline willingly fly something this expensive? Because most of that money doesn't come from economy tickets. Below the cabin sits an enormous cargo hold, flowers, medical supplies, electronics, even racehorses, and on some routes, cargo alone generates 20 to 30% of a flight's total revenue. Upstairs, a single first-class suite can sell for well over $10,000, one passenger generating more revenue than dozens of economy seats combined. That's the part most passengers never think about. The luxury upstairs isn't just comfort, it's what makes the economics of the entire aircraft work. To understand the A380, you have to go back to the 1990s. Air travel was exploding, and for the world's biggest airports, that was becoming a nightmare. London Heathrow was reaching its limits. Frankfurt was packed. Tokyo Narita had almost no room left to expand. Building another runway wasn't as simple as pouring concrete. There wasn't enough land, communities opposed the noise, and regulations kept getting stricter. Airbus believed it had found the answer. Not more airplanes, bigger airplanes. Instead of flying 2 aircraft carrying 250 passengers each, why not fly 1 aircraft carrying more than 500? Fewer takeoffs, fewer landings, the same number of travelers. It sounded almost too simple, but that one decision would eventually reshape airports across the world. Most people think the A380 was just another aircraft project. It wasn't. It was one of Europe's biggest industrial megaprojects. No single factory could build it. The wings came from the United Kingdom. Fuselage sections came from Germany and France. The tail was built in Spain. Everything had to reach one final assembly line in Toulouse. There was just one problem. These parts were too large for normal transport, too large for trains, too large for standard cargo aircraft. So Airbus built an entirely new logistics system. Specialized cargo ships crossed the sea, river barges carried sections inland, and enormous road convoys rolled through small French towns in the middle of the night. Traffic signs came down, road shoulders widened, bridges were reinforced. Residents woke up just to watch giant aircraft sections crawl through their villages at walking speed, not because it was a festival, but because they knew they were watching engineering history pass right outside their front door. This wasn't a one-time event. Those convoys continued for almost 14 years, but while the public watched the aircraft slowly come together, inside Airbus, something was already starting to fall apart. The biggest threat to the A380 wasn't an engine, it wasn't the wings, it was software. Different engineering teams were using different versions of the same design program. On paper, everything looked perfect. In reality, nothing fit together. When electrical systems from different factories arrived for assembly, engineers discovered a disaster. More than 530 kilometers of wiring no longer matched the aircraft. Some cables were too short, others followed the wrong routes entirely. Imagine finishing a skyscraper only to discover every cable inside the walls has to be ripped out and reinstalled. That's essentially what happened. Thousands of workers went back to the beginning. The delay stretched into years. Airbus lost somewhere between $6 and $7 billion, and senior executives lost their jobs. For a moment, people genuinely questioned whether this aircraft would ever enter service. And surprisingly, that wasn't even the biggest challenge waiting for it, because even after the aircraft was built, nobody had answered where exactly this giant was supposed to land. Somehow, a machine weighing almost 575 tons lifts gently into the sky, as smoothly as an aircraft less than half its size. And the secret isn't the engines. Look out the window during turbulence, and you'll see the wings move. Sometimes by almost 4 meters. It looks terrifying. It's actually the design working exactly as planned. A rigid wing would crack under repeated stress. A flexible wing absorbs it, spreading force across the entire structure. During certification testing, engineers pushed the wings until they bent more than 7 meters upward before finally reaching their limit. But despite all that engineering, one decision made thousands of miles away in airline boardrooms would change the aircraft's future forever. The A380 was designed around one idea: move huge numbers of passengers through a few giant hub airports, London, Dubai, Singapore, then distribute them again with smaller planes. For years it worked, until another manufacturer asked a completely different question. What if passengers didn't want to connect at all? While Airbus was building the world's biggest aircraft, Boeing was quietly working on something much smaller. The 787 Dreamliner, built to fly directly between smaller cities without routing through a mega hub. Almost overnight, the industry changed direction. The A380 wasn't becoming outdated. The business model behind it was. Airbus believed airlines would eventually buy around 700. Production ended after only 251, and one number explains almost everything. 123 of those aircraft belonged to a single airline, Emirates, more than half the entire global fleet flying under one flag. In 2019, Emirates quietly reduced part of its future order, not cancelled, simply reduced. But for Airbus, that was enough. After 2 decades of development and more than $25 billion invested, the production line closed. The final aircraft left Toulouse in 2021. For many people, that was the end of the story. But one incident had already reminded the industry why every mystery surrounding this aircraft had to be solved, no matter how long it took. In 2017, an Air France A380 was cruising above Greenland when one of its engines exploded mid-flight. The crew safely diverted the aircraft. Everyone survived, but one critical piece of the engine had simply disappeared, fallen somewhere across one of the coldest, most remote places on Earth. Without it, investigators couldn't explain why the engine failed or guarantee it wouldn't happen again. So a search began that lasted nearly 4 years until teams finally found the fragment buried beneath almost 4 meters of solid ice. What they discovered inside surprised even the engineers who designed the engine: a previously undocumented type of metal fatigue. One recovered fragment changed how aircraft engines are inspected and manufactured across the entire industry. For years, the A380 became a symbol of failure. Analysts said the era of giant passenger aircraft was over and airlines parked their fleets or dismantled them for parts. But the original problem that inspired the A380 never actually disappeared. It was simply waiting. Today, international travel has recovered. Heathrow, Dubai, Singapore, Los Angeles, some of the world's busiest airports are once again operating close to their limits, and landing slots have become incredibly valuable. The same question Airbus asked 30 years ago has returned. If you can't add more flights, why not move more people on each one? Emirates didn't retire its fleet. It invested billions into it, launching one of the largest cabin retrofit programs in aviation history, modernizing more than 100 aircraft for decades of future service. Etihad brought its stored aircraft back into service, launching new long-haul routes once considered impossible to justify. Singapore Airlines and British Airways kept relying on the type for airports where extra flight slots are almost impossible to obtain. If success is measured only by sales, then perhaps the answer is yes. Airbus expected 700 aircraft, only 251 were built. But engineering isn't always measured in sales. The A380 forced airports across the world to modernize and pushed composite materials, wing design, and safety standards further than ever before. Many of the aircraft replacing it exist because of what engineers learned while building it. The Airbus A380 arrived with impossible ambitions, nearly collapsed under its own complexity, and survived billion-dollar mistakes. It changed airports, changed engineering, and then quietly disappeared, only to begin returning the moment the world faced the very problem it was built to solve. Maybe Airbus didn't build the wrong airplane. Maybe it built the right airplane for the wrong moment in history, and judging by what's happening today, its final chapter may not have been written yet. So what do you think? Was the Airbus A380 a billion-dollar failure, or simply a machine that arrived before its time? Let us know in the comments below. And if you enjoyed this documentary, don't forget to subscribe for more mega project stories. Thanks for watching.